Hello everyone, this is Nandini. I'm here today to discuss about CKY parsing. In this, I'm going to discuss about all these sections. First, I will introduce what is the parsing, and I will tell you about the briefly about which domain I have selected. That is library book search operation, and about the CFG grammar and lexicons which I have created based on the domain and sentences, and how we can convert CFG to CNF grammar, and how the CNF grammar is looking. And then I will be moving forward to show you the accepted strings CKY tables. Then we'll move to the rejected strings CKY tables, and then I will show you the parser script which I have created and the outputs of the parser. So let's dive into the presentation. So here, in introduction, let me introduce this CKY parsing. CKY parsing means it's a calculation for context-free language, which was developed by Koch, Enger, Kasami scientists. So that's why it is called as CKY. It is employed it is a dynamic programming and bottom-up parsing. Actually, it will be used for dynamic programming and bottom-up parsing, and it is used to validate the string based on your given grammar. That means it will say like whether the string is accepted by the grammar or rejected by the grammar. And this algorithm is also known as membership algorithm. Coming to the domain which I have selected for this project, um, I have selected library book search operation. So this is the brief paragraph or brief things about how we are going to search for a book in your library. So based on this only, I have developed 15 sentences which we are going to validate by using CKY parsing algorithm. So if you see here, this is the CFG grammar, which I have created based on the sentences which I have chosen. Here, every grammar will start with S, and here NP means noun phrase, VP means verb phrase, and here auxiliary grammar will be there, adverb, adjective grammar will be there, and here that means determiners will be there, and prepositions, adjectives, and so on. So, and also I have created lexicons for my sentences, which tells us what are all the nouns, verbs, prepositions, adjectives, adverbs, and so on. It's basically tells the grammar of sentences. That's it. So the next step is converting this CFG grammar to CNF grammar. This is the main step before performing CKY algorithm for all the sentences. So to do this, there are three rules or three steps we can say. Here the first step is like we have to eliminate all the null productions, we have to eliminate unit productions, and the third rule is a non-terminal should represent either two non-terminals or only one terminal. So by using all these rules, we have to convert CFG grammar to CNF grammar. In this slide, we can see how our CNF grammar is looking. Here you can see all the non-terminals are representing the only one individual terminal or two non-terminals like this. So by using the CNF grammar, we are going to develop CKY parsing tables, which will be used to validate the sentences that are whether the sentences are accepted by this grammar or rejected by this grammar. So moving to the next slide, these are few examples of the sentences for which I have performed a CKY algorithm, or I have created CKY tables actually. Let me explain one sentence. All these sentences are accepted by the grammar. So let me explain one here. So here if you see, the library has books on many subjects. In this sentence we are having 7 words. How we can say a sentence is valid by the provided grammar is, if you see this S non-terminal in the top right corner of the CKY parsing table, then you can say the sentence is accepted by the provided grammar. Now, how to build this table? So let me, this is the sentence, and here these are the rows, or these are the number of words of the sentence, and these are the positions of the words. Like you can say 0 to 1, the, and 1 to 2, it will be library, 2 to 3, it will be has, 3 to 4, it will be books, and so on. And here will be having 7 rows. So let's build CKY table first. So the first coordinate is 0 to 1. So 0 to 1, that is the. Let's move to the CNF grammar and lexicons to see where this the is coming. In CNF grammar, no. In lexicons, you can see this the is coming under determiner. So here in this coordinate, I'm putting determiner here, that. And then moving to the second row. In second row, we have to start with the coordinate 1 to 2. 1 to 2 means it will be library. So let's see where this library is coming in our grammar. You can see in NP here, library is coming, means noun phrase. In under nominal, library is coming, and in lexicons, if you see, under noun, this library is coming. So um, in this CKY table and in this coordinate, I have to put all the non-terminals which represent this library. So NP, nominal, and noun. Then move to the next, move to the top coordinate 0 to 2. 0 to 2 represents the library. So we have to validate where this the library is coming in our grammar. For that, we have to take the combination, any one combination of 0 to 1 and 1 to 2 coordinates, like det NP or det nominal or det noun. We have to check whether that kind of combinations are present in our grammar. So let's check. Here, if you see under CNF grammar, you can see this noun phrase NP is representing det nominal. So here I'm putting NP here in this coordinate. Like this, I'm gonna build the CKY parsing table for the whole sentence. Here, if you see this cross mark, it represents there is no grammar representing these coordinates. For example, if you see here 3 to 5, if you take 3, means it will be like books, and 5 means it's ends on, right? Books on. So we have to see any grammar that is representing books on, but there is nothing like that. So I'm keeping cross mark here. Like this, I will be moving up to the last column, and I will be building these things with the help of CNF grammar and lexicons. And finally, if we see this S symbol in this subjects, I mean this coordinate 0 to 7. 0 to 7 represents the whole sentence, like it will start with the and it will ends with 7. 7 means subjects, right? The library has books on many subjects. So this whole sentence is representing by S. So we can say this sentence is valid by our grammar. Like this, I have developed all the CKY tables for 15 sentences, and 15 valid sentences and 3 CKY tables for invalid sentences. Moving to the next slide, here you can see the CKY tables for invalid sentences. If you observe here, the last, top right corner, there is no S. It's crossed, right? It means this sentence is not accepted by the provided grammar and it is rejected. So moving to the next slide, this is the parser which I have created using Python, and the tool is Jupyter Notebook. Here this will take input of one sentence and provide us the output either S for valid and no for invalid. In the next line, you can see the output of the parser here. I have given input of this sentence. The library has books on many subjects, and it provided me the output S. That means the sentence is valid. If here I have given this sentence as an input, and it given me the output as no, so this sentence is not valid. Now let me show you the demo of all the 15 sentences by using the CKY parser. So here all the 15 sentences, valid sentences and 3 invalid sentences. And this is my CKY parser here. So let me run this for all the 15 sentences. This is showing me yes. So the sentence is valid. The second sentence is also valid. Third is valid. Fourth is valid. And also I will show you the invalid sentences. Um, in the middle, yes, I have got one invalid sentences. And this is another example of invalid sentence. This is no. And this is the final invalid sentence, maybe. Let This is no. So this is how my parser is working. Um, and it's working fine. This is showing the sentences which are valid and which are not valid by the provided grammar. Um, thank you.